Hello, Geometry. This is part 2 of the 4.1 notes section. We already talked about the first 5, which was basically just, can you write these as if-then statements and then determine the hypotheses and the conclusions of each statement? Well, we're gonna delve into 2 other sections here. Oh boy, can't do that. So basically, the first section we're gonna do 6, 8, and 9, and 10, and I'm planning on doing 11, 12, and 13 with you guys. So this may take longer than the last video. It might need to be split up into 2 different ones. We'll see how it goes. All right, so the directions are: decide whether the statement is true or false. If false, provide a counterexample. So when I'm looking at the statement, the equation negative 3x minus 10 equals 5 plus 2x, it says it has exactly one solution. Well, I kind of want to confirm that it has exactly one solution, so I'm going to actually solve it, and we know how to solve equations. You get the x's on one side, get the constants on the other. This is negative 15. This is 5x. Divide by 5. So the solution is x equals negative 3. So my question is it true that this equation has exactly one solution? And the answer is, yeah. The one solution to this equation is x equals negative 3. That's the one solution. So that's a true statement. Done. Check number 8. For any real numbers a and b, so that's pretty much any number that you guys can think of, the absolute value of a plus b equals the absolute value of a plus the absolute value of b. So what they're counting on this assignment is that you have basic mathematical knowledge, like knowledge of what do absolute values mean. Well, absolute value basically turns everything inside the bars positive. So like if you had the absolute value of 3 minus or plus negative 2, that's going to equal 3 minus 2 is 1. The absolute value of 1 is 1. Similarly, if you had the absolute value of negative 6 minus 7, that equals the absolute value of negative 13. If you take the absolute value of negative 13, you will get positive 13. So that's what absolute value does. If you've forgotten, there's a little crash course for you. So my question is this true every time? Can I split up each of these and come up with the same answer? So let's just test it with one of these scenarios. So let's say you have the absolute value of 3 plus the absolute value of negative 2. Pretty much, we're testing this hypothesis with this particular situation. What's the absolute value of 3? It's 3. What's the absolute value of negative 2? 2. What's 3 plus 2? 5. That is not 1. So I just found a counterexample. This is not always true. It's false. And my counterexample is let A equal 3 and let B equal negative 2. If A equals 3 and B equals negative 2, then doing the left-hand side of the equation gives me 1. Doing the right-hand side of the equation gives me 5. So it's not always true. Check number 9. This has nothing to do with mathematics. If you visited the Jefferson Monument, then you've been to Washington, D.C. All right, well, I know that the Jefferson Monument is in Washington, D.C. If we went on a Google Map search and we search for the Jefferson Monument, it would give us an address within the limits of Washington, D.C. So if you visit a place that is in Washington, D.C., then you've been to Washington, D.C. This is true. So hopefully that makes sense to you guys. It'd be like if, well, no, that one doesn't work. Never mind. So we got number 9. Last one I want to talk about is number 10. We're back to mathematics. Two collinear rays intersect. All right, so we got some math language from the previous chapter. Let's see if we can make sense of this. So what does it mean to be collinear? It means they're on the same line. So let's say we've got this line right here. We'll call this A, B, and C. So some rays that are on the same line, you've got ray BA, you've got ray BC. Let's add another point here. What if there was a D there? You've got ray CD, you've got ray DA, DB, DC. There's a bunch of different rays to talk about here. Do they all have to intersect? The answer is actually no. Look at ray BA. Ray CD will never touch ray BA. There is this much of a difference between the two, so they actually don't intersect at all. It's false. What's my counterexample? It's this right here. My counterexample is to draw a line with 3 points on it. A, B, C, D. Sorry, 4 points. And all I got to do is say the ray BA does not intersect the ray CD. So that's my answer. It's false. There's my counterexample. And you know what? I'm going to do one more example that's not on the note sheet, but I think maybe will be a little more helpful to kind of like piece this all together. Stop the video and then I'll do the last part. I'll give you an extra one on my own. If you visited Casey's, and we're talking about Casey's General Store, then you've been to Colfax. Is this a true statement or is it a false statement? False. Counterexample? My dad has been to the Casey's in Carlinville, Illinois. I know because I was with him when we were there. But he's never been to Colfax, Illinois. That's a fact. So, I don't know. That's my counterexample. Now, you guys don't have to be so specific as that. You could have said, there are Casey's in towns other than Colfax, Illinois, but that's what it means mathematically to declare a statement true or false and then provide some kind of counterexample or reasoning. Because you just can't say true and false things without actually backing it up with a counterexample. All right, guys. I'm going to stop the video, and then we will talk about converse, inverse, and contrapositive.